This is review video 47, pH and pOH. So first of all, what does that even stand for? pH stands for the power of hydrogen, and pOH stands for the power of hydroxide. But in terms of what they actually mean, the pH and pOH scale are literally just an easy way to look at and conceptualize hydronium and hydroxide concentration with small friendly numbers that don't take a lot of thought to evaluate. One thing that I'd like to point out, though, is that the pH scale and the pOH scale are inverses of one another. And what that means is they are complete opposites. So if you are given a pH of 3, that's great. We know that acids tend to have pH values less than 7. But if a substance has a pOH value of 3, that is completely different. A pOH value of 3 is actually a base. So it's very important to pay attention to what numbers you are being given, because if you look at a pOH and mistake it for a pH, you will start doing your problems very, very wrong. So let's talk about them. An acidic substance is going to have an H3O plus or hydronium concentration that is greater than its hydroxide concentration, which makes sense. Hydronium is acidic by nature. Acidic substances have pH values that are less than 7, but they have pOH values that are greater than 7, because again, I said that those two scales were inverses of one another. If we have a neutral substance, that means that the concentration of hydronium and the concentration of hydroxide are equal to one another. Their pH will be equal to 7 and their pOH will be equal to 7. Again, your substance that you need to know is neutral would be water. And it makes sense as to why water happens to be neutral, because water is literally made up of a hydrogen and a hydroxide. It's made up of an acidic and a basic substance, so putting together makes it neutral. Our basic substances are the opposite of acids. They have a hydroxide concentration that is greater than their hydronium concentration. They have pH values that are greater than 7, but pOH values that are less than 7. One term I'd like you to be aware of is the term alkaline. The term alkaline and the term base mean the same thing. So basic substances are alkaline in nature. And that's what the alkaline earth metals were named after, because if we have alkaline earth metals in our water, it makes our water slightly basic. So smart water and things like that, they tend to have alkaline earth metal ions in them, and it makes it a slightly basic solution. So if we're looking at this scale right here, we see that our acidic substances are on the left here, whereas our basic substances are on the right, and our neutral is directly in the middle at 7. We can see our pH scale is actually pre-generated for us. We can see right here it starts at 0, which is very, very acidic, and it ends at 14, which is very, very basic. But below that, you are seeing the hydronium concentration. So I'm going to point this out so that you can kind of evaluate concentration versus pH very, very efficiently. A pH of 1 means that your hydronium concentration is 10 to the negative first. A pH of 2 means that your hydronium concentration is 10 to the negative second, so on and so forth. So whatever your pH value is, that's probably going to be pretty close to the magnitude of your concentration. But if we look at our pOH scale or our hydroxide concentration down here, we can see that it's flipped, right? Whereas for our acids, 1 was over on this end. For our bases, 1 is over on that end. So if I were to just superimpose the pOH scale, we would see that this is a pOH of 0. That's a pOH of 1. That's a pOH of 2, 3, 4, 5, etc., etc., etc. So again, that scale is flipped and you have to be aware of it. In terms of how to calculate pH and pOH, I have this fun little map here. And if you took baby chem with me, you already have this map. You've seen it before because we did a bunch of these calculations back then. The first thing to pay attention to is up here at this side. It says H plus concentration, But remember, we can use H plus and H3O plus interchangeably. So it is okay if a problem gives you H3O plus, you can still use this map without an issue. If you have an H3O plus or an H plus concentration and you want pH, all you have to do is follow the down arrow. And it tells you that pH is equal to the negative log of the H plus concentration, which is just calculator work. If instead you have a pH and you want H plus, you just have to go up. And to go up, we take 10 and we raise it to the power of negative pH. You'll see that over on the right-hand side, our hydroxide to pOH is much the same. To go down, I want to take the negative log of that hydroxide concentration. To go up, I want to take 10 and raise it to the power of negative pOH. Going back and forth between pH and pOH is very, very simple. If I have a pH and I want a pOH, I just take 14 and subtract pH. If I have pOH and I want pH, I take 14 and subtract it. Again, that's very, very easy to do. Going back and forth between H plus and OH minus on the top up here is also fairly simple to do. I find it clunky to plug into a calculator though, so I tend to avoid it if I can. But if you have hydronium and you want hydroxide or vice versa, all you're going to do is take 1 times 10 to the negative 14th and divide it by the thing that you have, and that will allow you to travel back and forth. So let's do a couple of examples here. Our example says calculate the pH for each of the following. The first one says that the pOH is equal to 7.5. If I go back to my map, I have pOH and I want pH, so I'm going to follow that left arrow, and it says I need to take 14 and subtract the pOH. Great. So I'm going to take 14, subtract 7.5, and that's going to give me a pH of 6.5. Great. Amazing. Done. Easy. This next one says I have an H3O plus concentration of 1.2 times 10 to the negative 4th. So again, I'm going to go back up to my map. I have this and I want pH. So I'm going to follow this down arrow. I'm going to take the negative log of that concentration. So my pH is equal to the negative log of 1.2 times 10 to the negative 4th. And I'm going to take a second and plug that into my calculator. And that gives me a pH of 3.9. So real quickly, I would like to point out, we saw that our concentration had a magnitude of negative 4, 10 to the negative 4, so my resulting pH is very close to 4. Again, that's kind of a guess and check. If you look at your magnitude and your pH ends up close to it, you'll know you're doing it right. All right, last practice problem. We see that I have a hydroxide concentration. I still want pH. My hydroxide is 6.5 times 10 to the negative 3rd. So I go back up to my map. This time I'm all the way over here, and I want to go left and then down. Or alternately, I could go down and then left. Personally, I like going down and left. Again, I told you that I find this stuff very clunky to plug into a calculator. So I'm going to go ahead and follow that down arrow to get my pOH and then subtract from 14 to get my pH. So I'm going to take that negative log of my concentration, 6.5 times 10 to the negative 3rd. That's going to give me my pOH value, not pH. Remember, we're taking 2 steps. So my pOH is 2.2. I'm just going to label that for ourselves. Once again, we see that my original magnitude of my concentration was negative 3, and so 2.2 is close-ish to 3. Again, the bigger that this number gets, the farther off you're going to be. But again, it's close enough to 3. So to get pH, I'm going to take 14, and I'm going to subtract my pOH value from it. And that gives me 11.8. Once again, I would like to remind you about sig figs. So rather than rounding this to 12, which I know it looks like you should because there's 2 sig figs in both of those numbers that I just used. Remember, when you do subtraction, you need to round to decimal places. And 14 does not count as part of those decimal places because 14 is considered an exact value. So whatever number you started with, this has 1 decimal place and we did subtraction. So my answer should in fact have 1 decimal place attached to it, which 11.8 absolutely does. And that's my final pH. If you have any questions, please feel free to ask.